Okay, we're moving to Daniel Rivera from Arizona State University. Daniel, today, throughout the course of the day, we've heard much about the importance of engaging stakeholders in this process, all the way from upfront and the mapping efforts, if you will, continuing on into the modeling work and maintaining that relationship. What are some ways in which we can initiate community and stakeholder engagement in the modeling process? And what kind of strategies would be helpful to get everybody on the same page?
Yeah, so thank you, Nikos, Nick, for the question. Nick. And I guess what I'd like to do is maybe also provide some context, as some of my fellow panelists have done. And I'm a chemical engineer who specializes in control systems engineering, and worked in diverse aspects of control systems, from traditional process control to basically being involved in problems in behavioral medicine for the last, well, it's 18 years since I first got interested in the subject, and probably it's getting close to 15 since I really got serious about it. So many of the individuals who I work with, I guess the stakeholders from my perspective, are intervention scientists, behavioral scientists who are interested in delivering optimized interventions, personalized interventions. So that's more of my, so I am a modeler, and I am involved in a class of problems that hasn't necessarily been discussed so much during the day. Now, we've had some great presentations throughout the day, and in particular, the Salubar project went into a lot of detail in terms of very detailed strategies for participatory model building, community engagement, and that kind of thing. So maybe I can speak a little bit about things that are related to working with behavioral scientists interested in optimizing interventions that could be related to obesity, weight management, or also physical activity. Many other things are still the same. You have issues of language and domain expertise, and there's always a little bit of tension. And one thing I would contribute is that, from the modeling standpoint, there are things that I have learned becoming involved in this work that have sort of expanded my scientific understanding. So, for instance, I would say that my understanding of what an experiment means has been broadened a fair amount as a result of being involved with behavioral scientists. I would quote Linda Collins, who sort of she used to be at Penn State, now she's at NYU, who her quote was, "Well, engineers think that if you just poke on something and get data, that's an experiment," and that's clearly a very limited view. So that has been part of my own personal development. Now, what I have found useful is that we go through, in our case, getting groups to draw path diagrams, which come from structural equation modeling. They don't have to be formal path diagrams, but that usually is enough for us to sort of get started. And in fact, that's a process that becomes iterative as well, because ultimately, we end up getting dynamical models that are used for intervention optimization. And in fact, in our case, we focus a lot on ideographic single subject models. So we try to get folks to write up a path diagram as or a reasonable facsimile. By the way, let me mention, I'll mention this before I forget it, that 2 weeks from today, I am presenting a webinar with the NIH Office of Disease Prevention in their Mind the Gap webinar series. So in fact, 2 weeks from today at 2:00 Eastern, and notice for that is already up, and anyone who wants to hear a little bit more about what we do specifically can tune into that. It's a free, openly accessible webinar. So there are some theories that are already amenable to, like, for instance, theory of planned behavior, which some of the groups that we work with use a fair amount. We've actually done work to put that in a dynamical systems context, and that's one approach. We also, in fact, we went through an effort where we actually developed a dynamical systems model for social cognitive theory that's also relevant to a lot of health behavior. And the interesting thing about that is that even though social cognitive theory is well regarded and the work of Bandura is well recognized, there are actually not any good path diagrams out there for it. So we ended up developing a dynamical systems model, which has a fluid analogy, which is similar to the stock and flow models that are used in system dynamics. And actually, from our work, you can actually backtrack a path diagram if that is useful to folks. So, so I would, those are again specific steps that that we have taken. Also sometimes we mix and match. Like for instance, there's a lot of the theory of self-regulation is well appreciated by a lot of folks, and sometimes you sort of put them together with something else, and that is useful in getting some kind of model, which then can be then ultimately tested. And a lot of what we do ultimately we want to try experimentally. And I will go back to some of the things that Jack Homer said at the very beginning of our workshop, because we're interested in testable models, and then we're also interested in models that are good enough. And many times our goal is to, through our process, get to a simplest model that helps answer some of the basic questions. And that's better than just thinking about every aspect of complexity, every possible construct, every possible contextual variable that could influence the phenomena. So I guess that would be what I would share as in addition to all the great things that have been discussed during the workshop today.
Great, thank you. I appreciate the idea that it is important to keep in mind that anchoring what we do in modeling with strong theoretical foundations is important, and that's a good fit as well. Chris?